This can be a very easy question if you know the techniques. So the answer to this question is here, A. And I will show two techniques. One, for comparison questions like this, I've always taught all of you to do this technique. Simple technique, just find an equation, the correct equation though, and then write it both times for both objects, and then find a way to connect these two equations simultaneously. And then when you look at the equation that you combine simultaneously, manipulate a little bit, and you should be able to get the answer that you're looking out for. So how do we do this for this question is here. So you learn about the formula resistance of a straight wire is rho L over A. That is the equation to use. I rearrange the equation to make resistivity the subject of the equation, because these two wires, the common or the similarity, the similar point is that this are made of the same resistance wire. So the material is the same, the resistivity for both wires must be the same. So I've made resistivity the subject of the equation, and then that's how I can connect equation for the first wire with the equation of the second wire. And with that, it's just a matter of plugging in the values, or you just do the algebra carefully. And with that, I got this resistance of the first wire is R, the area is A, and the length is L. And in the second wire, we double the resistance is found to be doubled. The area is told to us that is 1/4 of the original area, and you are left with L2. Rearranging the equation, you get L2 to be half the original length. Now, what I want to share with you is also a second technique. This second technique is actually a lot faster, but you must know how to use this. So we know that for this second technique is basically using proportion. So we know that resistance is proportional to length from the equation itself, or just from the reasoning. The longer the wire, the more the resistance. So if the second thing that we know is resistance is inversely proportional to area. The bigger the area, the smaller the resistance. So these are two facts that you must know. So if you are told that the area is now 1/4, this means that with this change itself, the new resistance must be quadruple, 4 times, because it's inversely proportional. All right, so if we just modify the area to be 1/4 of the original area, the resistance, the new resistance, must be 4 times. But is that the case? If you read carefully, no. We are told that the new resistance is not 4 times, it's only 2 times. So from 4 times resistance, the end result becomes a double the resistance. There's the factor of half. So that means the effect of the new length must halve the resistance. And what do we do with the length to halve the resistance? You halve the length, and that's how you can get half L as the answer. So this second technique is a lot faster. I've shared this in class also. If you need someone to talk to on this shortcut method, find out friends or just approach me during your breaks.